Hello everyone. Today I'm going to present a topic from artificial intelligence called multilayer perceptrons and backpropagation. These concepts are important in understanding how modern neural networks learn from data. Multilayer perceptron, commonly called MLP, is one of the basic models used in artificial neural networks. It is widely used in machine learning and deep learning for solving problems such as classification, prediction, and pattern recognition. In this presentation, we will understand the structure of multilayer perceptrons and how the backpropagation algorithm helps the network learn from data. A multilayer perceptron is a type of artificial neural network made up of multiple layers of interconnected neurons. These layers work together to process input data and produce an output. MLP models are powerful because they can learn complex patterns from data, making them useful in applications like image recognition, speech processing, and data prediction. The architecture of a multilayer perceptron consists of three main layers. The input layer receives the raw data. The hidden layer processes the information through several neurons and mathematical operations. Finally, the output layer produces the final result or prediction based on the processed data. Zooming in on the individual neuron. Networks are powerful because of their scale, but the actual computation happens at the microlevel. Every network is built from individual neurons that receive, process, and transmit data. Each neuron in the neural network performs several steps. First, it receives inputs from previous neurons. Each input has a weight that represents its importance. These weighted inputs are summed together and pass through an activation function to produce the output of that neuron. Activation functions determine whether a neuron should activate or not. They introduce nonlinearity into the model, allowing the network to learn complex relationships. Neural networks do not automatically know the correct weights. They must be trained using a learning algorithm. The most common algorithm used for training neural networks is backpropagation, which adjusts the weights based on the error in predictions. In backpropagation, the error is sent backward through the network. The algorithm calculates how much each weight contributed to the error and adjusts the weights accordingly using a technique called gradient descent. This helps improve the model's accuracy. There are three phases. Phase 1, initialization and the forward pass. Step 1, initialize weights randomly across the entire network. Weights are assigned small, random values to break symmetry, setting the starting point for the network's learning process. This is a state of complete uncalibration. Step 2, perform forward propagation. The network processes the input data layer by layer through its current random weights to generate an initial, untrained prediction at the output layer. This first pass is purely calculative and not expected to be accurate. Phase 2, calculating the error. Step 3, calculate output error. The algorithm mathematically determines the difference between the network's forward propagation guess and the actual correct answer. Phase 3, propagating and updating. Step 4, propagate the error backward through the network layers. Step 5, update weights using gradient descent. Every weight is incrementally adjusted to reduce the error for the next pass. Phase 4, the continuous loop. Step 6, repeat the entire process. Forward pass, error calculation, backward pass, and weight updating continue continuously until the overall error becomes very small and the model learns correctly. The advantages of multilayer perceptrons. Handles complexity. Uniquely capable of modeling highly complex, nonlinear problems. Autonomous learning. Automatically learns features and relationships directly from the provided data. Industry standard. The foundational architecture, widely utilized across modern deep learning system. Real-world applications are image recognition, speech recognition, medical diagnosis, pattern recognition, data classification.